We do limits of trig as well, but we're going to do them after the unit test because they are more AP material than normal. So I'm going to show them to you, but not test you on them.
Unit test, not like for limits, but like stuff for that.
Like other functions and stuff?
Yeah. Like
in May. Because you go back to it in May. You're May the 4th, and then after that's 30-1.
Is it, so wait, our AP exam, is it just like this?
All right. So the derivative, d over dx of sine x, is cos x. So if you take the derivative of sine x, you get cos x. The other thing to remember is if you take the derivative of anything that starts with a c, your derivative is negative. Anything that doesn't start with a c, your derivative is positive. So the derivative of sine x is cos x, but the derivative of cos x, because it starts with a c, is negative sine x. So you just have to memorize them. The derivative of tan x, because it doesn't start with a c, is positive. It's secant squared x. And then we have the derivative of the other three. So we have d over dx of cosecant x. Cosecant starts with a negative, or starts with a c, so it's going to start with a negative, and it's cosecant cotan. You have to remember the x's because that's appropriate. And then you have secant. It doesn't start with a c, so it's positive. I think it's secant x tan x. My brain has to remember them. Yep. And then you have cotan x, which is negative cosecant squared x. So those have to be memorized. That's the only hard part about trig. And we're doing the very, 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 very basic trig ones today. So we're not doing like tan 2x or anything like that. It'll be like just tan x or just cos x or just sine x. Okay? So say I ask you, determine y prime if a y equals x plus 4 sine x. So y prime, what's the derivative of x? 1. And we don't have to do product or quotient rule because these are just addition or added, which is added, you know? So we can just go ahead and do them. Now when we have a number in front, you just rewrite that number and then take the derivative of this. So what's the derivative of sine? Cos. So it's going to be plus 4 cos x. And that's it. Tomorrow we're going to do a chain rule where we're going to actually have like a number in here possibly. Like a 2x or something. We have to do a little bit extra when that happens. But not today. B. X squared sine x. What are these two? Starts with an M, rhymes with multiplied. They're multiplied. Yes, they are. They're multiplied with an M, multiplied. If they're multiplied, then if you multiply them, we have to do what? Product rule. It's not an option. You have to do product rule. So this is F This is G. F prime is what? 2x. And G prime is cosec. So then you get y prime equals f prime, which is 2x, times g, which is sine x, plus g prime, which is cos x, times f, which is x squared. Now, before I say we're done, I have to say, is there something I can take out of the two terms? Because this is one term technically all multiplied, so is this. Is there anything I can take out of there? An x. So I'm going to go x, 2 sine x, plus x cos x. And I write the x first always, because it's not to be like cos x, which that's just confusing, right? And sometimes it's less confusing as well if you actually bracket the x by the cos and the sine, so they don't like attach. Okay, you're going to try C. Y equals sine x over x. What rule am I going to have to use? So that's going to be f prime. Didn't write that at all. Cos x times g, which is x, minus g prime, which is 1, times f, which is sine x, all over x squared. So I'm going to get x cos x minus sine x over x squared. That's as good as it gets. Tomorrow is when the lessons get real good. Tomorrow is when a lot of stuff happens. Chain rule, when life changes in derivative land. Okay. Y equals e to the x sine x. Try that one out. What's happening with these two? They're being multiplied. So we have to do got it. So f prime is e to the x, g prime is cos x. So we're going to get y prime equals e to the x, which is f prime times g, which is sine x, plus g prime, which is cos x, times f, which is e to the x. And then I can take e to the x out. Whenever I have a derivative with an e to the x, I can always take it out, even if it's an e to the 2x, because that will always, you always rewrite it, right? Derivative of the exponent, ln of the base. So you'll always have it, because you will always rewrite it, even if it's the derivative or the original. So when there's an e, you'll always be able to take a GCF out. So it's e to the x, sine x plus cos x. Okay, D. That is an E. I have no idea what you're talking about.
Magic.
It's a magic E. It's a Harry Potter E. That's the lightning bolt. Yeah, it's recorded. Can't even go back on it. All right. F of x equals x squared plus cos x. I'm not x squared plus cos x, sorry, x squared cos x. I'm multiplying them. So this one is product rule, and I always put like the dot in between so I remind myself that it's product rule. So this is F, this is G, F prime is 2x, G prime is negative sine x, because when you take the derivative of anything with a c, your derivative is negative, right? So the moment we take it with the cos, your answer is going to be negative. So we have f prime of x, I already said y prime up top, but whatever. F prime of x equals f of x, f prime of x times g plus g prime times f. You take an x out, you're left with 2x cos 2 cos x. Yep. And then often they'll put the x to the front and leave the minus sign in front of that. So they'll go minus x sine x. So that's that one. This one's derivative. So f g is closure rule. F prime is negative sine theta. G prime, 1 just goes away, and negative sine. So this is what, if the minus signs and stuff in front confuse you, just keep them and then do the derivative of sine. So minus, and then the derivative of sine is cos theta. So the derivative of negative sine theta is actually negative cos theta. I'll keep the negative sign in front and just take the derivative of what it is and then put it in with it. So my brain doesn't have to overthink that it's the opposite. So then I'm going to get g prime theta. So I get f prime, negative sine theta, g, 1 minus sine theta, minus g prime, which is negative cos theta, f, which is cos theta. So I'm going to get negative sine theta plus sine squared theta plus cos squared theta. And most people will get to here, but they're going to forget something. This is where we can use any of the trig formulas off of our Math 30-1 sheet, and it's not given to us, right? Whenever you see a sine squared theta plus cos squared theta, what does that equal? Sine squared theta plus cos squared theta. Pythagorean theorem. 1. That turns to a 1, so we actually can write it as negative sine theta plus 1. So what if I give you g? I have no idea what you're talking about. This happens way too much, just so you know. It's a real problem. It's 1 minus sine theta. Oh, I can keep going. So you're going to get 1 minus sine theta on the top. And then a 1 minus sine theta squared. You have to watch self quotient rule. I do that randomly every so often. So what I used to do to get myself to stop doing that is when I do the quotient rule, I immediately do the denominator and then do the numerator on top of it after. And it stopped me from doing that. Okay. G, y equals tan x minus sine x. And h y equals e to the x secant x. We're going to try the other derivative. So when we do the derivative of tan x, it's secant squared x. And then minus the derivative of sine x is cos x. So y prime equals secant squared x minus cos x. And then this one, f g, f prime is e to the x, g prime is secant x tan x, So y prime equals e to the x f prime times g, which is secant x, plus g prime, which is secant x tan x, times f, which is e to the x. I can take out an e to the x and a secant x only because the secant x is multiplied by the tan x, right? If there was like an addition sign in there or something, then it would have to stay. So we get e to the x secant x, and so we get 1, so took that completely out, plus tan x. I think I wasn't recording that. Determine
Should we go check on them?
I think it's funny because this is 100% getting recorded into my podcast because when I use this mic, it's a conference mic, it'll like pick you guys up sometimes better than me. So I was picking up like Clay doing a smackdown. I don't know what's happening. He is not.
Is that just like giving directions?
He is just excited. He gets very excited. He's just happy. This is what happens when he's happy. Yeah. He's very excited. Something's going down. I don't know what. Like, someone's talking about Greenpeace. I don't know. You know? Recycling, maybe. Maybe that's up for debate right now. But it's exciting. It's exciting. Okay, F double prime. None of my teachers were that excited about social ever. Would have been nice. Ours just played war videos. Like on a reel.
I like how he decided, he was like, should I teach them or should I teach them? And he just decided to.
Totally teaching. Okay.
Can we please go
No.
and see what's happening?
If f of x, we can go on a field trip in a little bit. If f of x equals secant x. So, do you need to simplify it if I'm giving you a value to fill in? No. Find your first derivative. You might need to simplify it so that you can actually find the second derivative though, right? Like it might be easier, it might not be. You might have to do. This one isn't a big deal because it's going to end up leading a product rule, but sometimes you do. Try that one out. So this previous one, f prime of x would equal secant x tan x, which is a product rule. So f double prime of x would equal f g f prime is secant x tan x, g prime is secant squared x. So we would do f prime, which is secant x tan x, times g, which is tan x, plus, I'm trying to talk over it, g prime is secant squared x times f, which is secant x. So you can simplify it if you want to. Secant x tan squared x plus secant cubed x. And we're doing it for 45s, right? So we're doing secant of pi over 4 times tan of pi over 4. And that squared in the middle just means tan of pi over 4, the answer, squared, right? Plus secant of pi over 4. And that cubed in the inside means the answer, cubed. So secant of pi over 4 is just root 2, I believe. Because it's root 2 over 2, right? Then you flip it, it's going to be 2 over root 2. Rationalize it is root 2. Because you'd go 2 over root 2 is 2 root 2 over 2, which is root 2. So we're going to get root 2. Tan of pi over 4 is my favorite. It's just 1. It's root 2 divided by root 2 over 2. So it's 1 squared plus root 2 cubed. So here we're going to get root 2 plus root 2 cubed. Is root 2 cubed an answer? Oh, my stomach just made noises. Type root 2 to the power of 3 and type it in. You should realize it's going to get you a decimal, correct? But root 2 cubed can be just rewritten like this. Root 2 plus root 2 cubed means the cube can come underneath as well, right? The cube can stay outside or it can come underneath. So it just means that there's a 2 cubed under here. Right? 2 times 2 times 2, which is really just the same as root 2 plus root 8. Root 8 can break down into what? 2 root 2. And when you have radicals, you can add them if they have the same radicand, same number as the radical. So 1 root 2 plus 2 root 2 is 3 root 2. This example here is a word problem. I just wrote down, that's an L. So L of t equals 2 plus cos t. So I'm going to explain it to you. So it says, an object hangs on a spring. So there's a spring on the roof, there's an object hanging on it, and the object bounces down and up and down and up and down and up, right? Because it has some weight. So it'll bounce up, then it'll go down, then it'll go back up, down. Now, making the spring 2 meters long in its equilibrium position. So 2 meters is going to be your middle, your midline, which makes sense because this is the same as saying cos t plus 2, right? And this would be my midline because it's my d value, correct? So that's where the middle of this, the equilibrium is at 2 meters. If the object is pulled down 1 meter and then released, it will oscillate up and down, and they say a function, so a steady function, it's going to be constant, even though that's probably not the case in real life. But it's going to be at a constant fluctuation. Okay? So the first question, it says, how does the length of the spring vary? How does the length of the spring vary? Now, they said we pulled it down 1, right? So that's why there's a 1 in front of here. What's the 1 in front of your equation? What's that? It's what? It's your A. It's your amplitude, right? It's how much it can go up and how much it can go down. That's why there's a 1 there, because they said they pulled it down 1, correct? So how does the length of this spring vary? Well, its midline is at 2. So its maximum is going to be d plus amplitude, correct? So it's going to be 2 plus 1. So this maxes out at 3 meters. It's a really long spring, just so you know. And then it's d minus amplitude, so you get the minimum. And they said they pulled it down by 1, right? So it's 2 minus 1, so it mins out at 1 meter. Like I said, long spring. Okay? Then it says, find the velocity of the object. What the heck does that mean? When this is just its normal displacement distance function. What's it asking me to do? First derivative, so go do that. So you're finding L prime of t or V of t. Everyone should have gotten negative sine t, right? Because the 2 goes away, derivative of cos t is negative sine t. C, let's see if you remember. C says, at what position, so what time, is the speed of the object at a maximum? At what time is it at a maximum? What does a maximum tell me? Yes, it tells me the slope, so m tan, which is the first derivative, right? Which is v of t in this case, is equal to 0. So what do they want me to do? Set v of t equal to 0 and solve, right? So 0 equals negative sine t. Divide by negative 1. Sine of t equals 0. Now it's a word problem, so it's in radians, correct? It's also calculus, so it's always in radians. There's no degrees anymore. They evaporate into space until May, when you go back to 30F. When is sine, which is y, equal to 0? At 0 and pi and 2 pi and etc. So we will just say, did they give us a restricted domain? So we just leave it there. The acceleration of the object. What's acceleration? Second derivative. So it's it's L double prime of t, right? Equals a of t. So if this is negative sine, it's actually going to be negative cos t. And then what else is that? So we answered what time? It was at a maximum. If they asked what position it would be at a maximum, it would be at a maximum at the position of 1, right? Or 3 meters was what it would be at its maximum position, right? That's the highest it went to. All right. So your homework is it's going to be on page 211. AP practice. Oh, the one thing I forgot to do is, what if it says the tangent line is horizontal? The first derivative just equals 0. That's the same as the max. Yeah. So 1, 2, 1. One to 9. And then the questions I want you to do. Are numbers 17 to, I'm going to do random ones because I don't want that many. 17 and then 23, 31 and 35. 45. 55. Now, keep in mind, if it's like 4 tan x, that the derivative of that was 4 secant squared x, right? Like I told you, the number just sits out front. Everyone's really good with that. If I replace the 4 with a pi, you guys just get blown away. If it's pi tan x, it would just be pi secant squared x, right? Pi is just a number. Don't let it throw you off. Okay? They throw pi in randomly all the time, and then people want to do like, they're like, it's a triple product rule. Pi is not a variable, pi is a number, right?